All right, everyone. It is Tuesday night. The sun has gone down, and we got some questions to answer. So you know it's tutoring night here again at La Casa Sardui. So let's get into this. I'm going to start with our Precalc questions. There are 4 of them for us to look at today. And then there's actually, drumroll please, our first ever calculus question to look at. So let's get into it. So starting with our pre-cal questions, all of these are coming from assignment number 3, which was on composition of functions. So in 7 and 10, I went ahead and I put the graphs here. We were asked to make the graph of h of x, and they tell us that h of x is f plus g of x. Now, right out of the gate, I want to say that this does not mean f plus g times x. All right, if you are not familiar with the notation or you're still shaky on it, I recommend going back, watching the videos that I did with function notation and compositions of functions that were put up onto the YouTube page earlier, so that way you can, again, be clear on what this is telling us. But this is not f plus g times x, because I did see a few people write it that way and got incorrect answers. So what we're going to do is we're going to go x by x value, get the values for f and g, and then add them up. So the best way to go about doing that is I'm going to make a chart. So here f, g, and then finally f plus, g. So we see for number 7, we got 4 points. Okay, so we're going to list those 4 coordinates. So we have a value at 0, then at 1, 2, and then 3. So x values. So 0, 1, 2, 3. Let me fix that one there. There we go. All right, so f, g, and then finally f plus g, which is our h of x that we're going to ultimately end up graphing. All right, so starting with f at 0, when x is 0, I see f is 2. G is -1, the values. Okay, so at 0, f is 2, g is -1. So f plus g would be 1. All right, next, when x is 1. Well, when x is 1, f is 3, g is 0. So f plus g would be 3. Then we get to 2. So when x is 2, f is 1. G looks to be at about a half. So f plus g would be 1.5. Then finally at 3, f is 2. G is again 0, meaning f plus g would be 2. So now I got to plot this graph. So here are my x values, and here would be the y values, because we already did the adding. So I'm going to graph it in red over here. So at 0, the answer is 1. At 1, the answer was 3. At 2, the answer is 1.5, so that puts it here. And at 3, the answer is 2. So this that I'm connecting in red, that is my h of x. So just that simple. So if it had said f minus g, then I would have subtracted these two, and I would have gotten those values and plotted accordingly. So that's all we're doing, is we're just using the values that are already present in the graph and conducting the function operation. So let's do it over here with number 10. Same setup as before. So I want to go ahead and I want to make my table again. So f, g, f plus g. So again, in the directions, they said we're adding these 2 functions together. So that's why I'm writing them f plus g. So this time we have what? -3 for x, then -1 and then 2. All right, so at negative 3, I see G is 1. F, however, is all the way down here at negative 3. So this time I'm going to write out all the y values for F and G first, and then I'll do the adding last. So G, so at negative 1, G is 2. So negative 1, G is 2. And F is at 0. Then finally at 2, we see F is at 2, and G is at negative 1. So now we'll add F plus G. So negative 3 plus 1, negative 2. 0 plus 2, 2. And 2 and negative 1, 1. All right, now we graph. So what is H going to look like? So at negative 3, the answer is negative 2. So we'll plot that point. Then at negative 1, the answer is 2. So that's up here. And then at 2, the answer is 1. And there's my h of x. So just that simple. So again, I'm going to write it over here. H of x was f plus g of x. So you see, I'm not multiplying. That's not what this means. The other way they could have written it, which would probably have made it easier to understand, but it's not supposed to be easy. They could have also just done this. If they did this, you would probably have gotten it. That is equivalent to what we see here. Also, they may just go simple and write that. All of these are equivalent. So again, if you're still confused about the notation, go back, watch the video, read the section. So I have a video specifically talking about notations. All right, moving on. Let's look at number 61. So we are asked to find the compositions f of g and g of f. Part B then says determine whether they are the same. So A and B are really going to go together because once we have A done, we'll have B and we can make a comparison. And then part C says use a graphing utility to complete a table of values to confirm your answer to part B. So we're just going to use our calculators to look at numbers, just to plug in numbers and see if it matches up with what we said in part B. All right, so let's start with this composition. So f of g. So remember, open dot means composition. So again, this is one way to write it. This means the same as if I wrote this. Okay, they are no different. So get used to the different ways that they may state the problem. Okay, so we're going to start with f of g of x. So we'll start by substituting. So I'm going to use a different colored pen here. So g of x is 4 minus x. So this is going to say f of 4 minus x. Okay, now I got to figure out, well, what's f of 4 minus x? So I go to my f function, whatever was x, so that x is now going to turn into 4 minus x. So it's going to say 5, 4 minus x plus 4. So you see how the x turns into whatever's in the parentheses. So it's this. All right, now we will simplify. So I'm going to distribute the 5. So this will be 20 minus 5x plus 4 for a final answer of 24 minus 5x. So there's my f of g of x. Now I need to get g of f of x. So let's write that over here. So g of f of x. All right, so we start with substituting. So now this is going to say, let me switch the pen color again. So g of 5x plus 4, because that was f. And now we go to our g function. The g function was 4 minus x. So we're going to replace that x with this. So it's going to say 4 minus x. So we can see, oh, I replaced the x in the g function with what I was plugging in, which is this whole expression. So now we clean up. 4 minus 5x minus 4 for a final answer of negative 5x. So there we go. So this is part A. So we got f of g of x, we got g of f of x. So part B says determine, are these two the same? Are they equivalent? So real simple answer to this one, are they equivalent? And the answer is no, they are not equivalent. They're nothing the same. So that answers our part B. And now it says to confirm using a graphing utility. So you're just going to use your calculator and you're just going to plug in values. So you'll plug in values here for your g of f of x. So, oh, okay, x is 1. So you just make a little table. That's all you're really asked to do in part C. You don't have to put out a bunch of values. I probably would just do 3. So, okay, x is 1. All right, so I go, okay, x is 1. So what's f of g of 1? So you'll figure that out. And then what's g of f of 1? Oops. Like that. So you'll do a little chart like so. So you're going to use your graphing calculator or handheld calculator, whichever one you want to use, just to help you get the numbers faster. So you don't have to sit there and just do it by hand. Okay, so you'll just plug those in. And again, just 3 values just to show something. And it'll just confirm what you're seeing algebraically. Yeah, these things will never be equal to one another. And if they are, it's a coincidence, but you're not going to consistently see that they're always equal. So again, let me just finish this example here with 1. So if I plug 1 into f of g of x, so if I would have plugged in 1, I would have gotten 4 minus 1, which is 3, times 5, which is 15, plus 4, which is 19. So I would have gotten 19 here had I plugged in 1. But if I plugged in 1 in the other one, what would I have gotten? So 1 times 5 is 5, plus 4 is 9, and then 4 minus 9 is a negative 5. So you already see with that first example, they're not the same. Now I can show a couple of other values. Maybe I throw in a negative, just for some variety. We want to spice things up. So I got at least 3 examples to really illustrate, look, these things are not going to be the same. So that's all you had to do for part C here. All right, so last question for pre-cal, and then we'll cut into our calculus question. So now, in number 69, we were provided 2 functions, but this time we just have their graphs. We don't have their equations. And now we have to figure out this composition. So remember, and this is what I would recommend to those of you, when you see this, if you get confused, like I have a hard time understanding what this means, rewrite it. So this is the same as saying f of g of 2. What is that equal to? So we start with the inside and we work our way out. Order of operations, right? Start with the parentheses and work your way out. So what is g of 2? So I go, okay, g. So that means I'm looking at this graph first. So at 2, the answer is 2. So g of 2 is 2. Okay, so now what do you have left? Okay, now I got to figure out f of 2. All right, so now we're going to go over to this graph. What is f of 2 according to this graph? Well, at 2, the answer is 0. And that's it. It's just that simple. It's getting the answer from 1, and then that answer becomes what we plug into the next one. So we're seeing numerically how does composition of functions work. All right, now let's look at part B. So part B, we're doing the same composition, but this time it is in the opposite order. So now it's g of f of 2. So I'm going to start with plugging in 2 into f first. So in the graph of f, at 2, the answer is 0. So this is 0. So f of 2 is 0. Now, what do we have to figure out next? Oh, what's g of 0? So I go to my G graph next. Oh, at 0, G is 4. And that would be my answer. So as I said in the videos with compositions of functions, that compositions are not commutative, meaning we cannot just switch the order around and get the same answer. It's not going to work. Things like addition, okay, multiplication, those are commutative functions. So you may remember that term commutative from pre-algebra, elementary math of, yeah, the order doesn't matter. 3 plus 2 is the same as 2 plus 3. 3 times 2 is the same as 2 times 3. So things that are not commutative. Subtraction, 2 minus 1 is not going to give me the same as 1 minus 2. The order matters. Compositions of functions, this operation with the open dot, is not commutative. The order makes a difference. It doesn't give me the same answer when I switch them around. So we just need to be aware of that when you're doing compositions, to not just go, oh, I already got this, so the answer over here must be the same thing. All right, so that does it for pre-cal. Let's flip over to cal, and we only got one question to look at, and this has to do with the last assessment that we did. So I'm looking is at question number 2. So it said to evaluate the following limit. So it was a piecewise function that we were looking at here. So it says limit as z approaches -2, and we have this piecewise function. Okay, so remember, the limit is what the function is approaching, not what the function equals or is as the input variable approaches a number. So we talked about when I have to evaluate a limit, especially ones with piecewise functions, I want to check, hey, what happens? So I'm approaching is -2. So what happens when I come from the left of -2? What happens when I come from the right of -2? All right. So if we're coming from the left of -2, numbers less than -2, which of the piecewise functions here am I going to use? Well, it's -2, which is less than 2, so it would be this piece right here. So I would be using z squared minus 2, because this number is less than -2. All right, this I know is a continuous function already. It is a polynomial. So I can just directly substitute to evaluate. So -2 squared is going to be 4, minus 2 is 2. All right, what happens when I come from the right? Numbers bigger than -2. But remember, we're still around -2, but we're just bigger than -2. So again, that's going to be this same function. It's not going to change because we're in that part of the piecewise function. So again, the answer is going to be 2. So the left hand and the right hand are equal, so therefore the limit as x approaches -2 for this function, this piecewise function, so you can write the whole thing again. I'm going to shorthand it. I'm going to say all this is equal to, and I'm going to say whatever, g of z. So I'm using x here as the variable, so I'm going to say g of x. But you get what I mean. It's the same function. The variable doesn't matter. So this is going to equal to 2. So here's where some people got kind of hung up on this. They didn't pay attention, and I'm going to tell you the common mistake I saw with a lot of people. They didn't pay attention to this. They solely got focused. They got tunnel vision. They looked here. So what they did was not the limit as approaching -2. People did the limit as they approached 2. So then, oh, when it's less than 2, it was this, so I got 2. But when it was greater than 2, I would be this function. So 2 squared is 4, plus 5 is 9. And then people would have said, oh, so this does not exist. Which is true if we were approaching 2. But you were not asked to approach 2. You were asked to approach -2. So if you got it wrong, you fell for my trap. And my trap is a trap that has been laid year after year by College Board to see if you are carefully reading. So if you fell for it, that is a lesson for you to learn. Read the limit notation carefully so that you don't fall for that trap again. All right, guys. So it is time. We have finished our questions. If you found this useful, as always, hit the like, subscribe to the channel, let me know what you think, and I will see you guys again here on another tutoring video.